Hello, everyone. Welcome to the third chapter of linear algebra. In this chapter, we're going to look at two operations defined on square matrices only, determinants and inverses of square matrices. The most interesting examples for us will be for 2 by 2 and 3 by 3. So the logic of this chapter is I will first introduce determinants for 2 by 2, inverses for 2 by 2, then we will do the exact same thing for 3 by 3. So first section, what is the determinant of a 2 by 2 matrix? Before talking about 2 by 2 determinants, because I want to have like a chapter that is covering everything from the start, we should talk about determinants of 1 by 1 matrix. So the first definition, what is the determinant of a 1 by 1 matrix? I will do the definition. I will show you one example, and we will never do this again because it's not very useful. It's kind of trivial. So if you start with a matrix A 1 by 1 matrix, so a matrix where you have one row, one column, and there's only one real number inside, the determinant is an operation that takes a matrix and constructs a number. And for a 1 by 1, the determinant, we're going to denote det A, and it's always going to be using that notation. So det, and in bracket, the matrix that interests us. So the determinant of A is simply going to extract that coefficient and spit back that entry. So that A, so capital A is small a. So it's extracting the entry. And very interesting remark here, all of this is quite pointless. Okay, so the real definition, the real computation will be for a 2 by 2 determinant. So what is the determinant of a 2 by 2 matrix? Suppose you have a matrix A with 4 entries. So on the first row, A and B. On the second row, C and D. The determinant is a number. And the way you're going to compute that number is by using this formula. That A is AD minus BC. So you just have to remember the formula. Of course, in this class, you're allowed to use a formula sheet. So you should have that formula in your formula sheet. But the way I like to remember this formula is by using a trick of introduced by a colleague of mine. He likes to draw a little fish in the matrix. So if you draw this fish in the matrix like this, and you follow that fish, the formula, and you draw that mouth. The mouth is very important here. So if you trace that fish, you're going to get A times D. And when you're going through the mouth, you get that minus B times A. That's one nice little way to remember the formula for a 2 by 2 matrix. Again, that's a formula or a trick that only works for 2 by 2. All right, let's just do a bunch of examples of computations of determinant for 1 by 1 and also 2 by 2. My first example, I have a nice 1 by 1. I want to compute the determinant of that matrix. So for 1 by 1, this is the only example I'm going to do. This is the only example you're going to see. We're not going to be interested by 1 by 1 determinant. But anyways, just for a sense of completion. So the determinant basically just removes the entry out of the box, okay, and you get a nice -2. We're geniuses. All right, so the real first examples are nice 2 by 2 matrices. So B, again, here I'm going to use a fish trick. So I draw the fish, and I want to compute det of B. So here, using the fish, it's 3 times 5 minus, when I go through the mouth, 7 times -2. So here, just be careful, do your math correctly. So 3 times 5 is 15, minus 14, and you get plus 29. And that's your determinant. Again, here, the result of computing a determinant is always a number. So what about C? You should remember C as being the identity matrix 2 by 2. So filled with zeros except on the diagonals, on the diagonal where you have a bunch of ones. So let's compute the determinant. So again here, big fish person here, I draw the fish. So let's go. If I compute the determinant of 1, 0, 0, 1. I'm going to, by following the fish, get 1 times 1 minus 0 times 0. So I'm going to get 1 minus 0, and you're just going to get a nice clean 1. So one more examples. Again, nothing too deep here with 2 by 2 determinants. Just take your time. So be careful with some negative values. So let's compute the determinant of D. So I guess, again, I will draw my fish first. So let's go. Okay, so determinant here of D, which is 2 minus 6 minus 10 and 30. Following that fish here, I get 2 times 30 minus 6 times minus 10. Following my fish, I get 60. Be careful, minus 6 times minus 10 is plus 60. So you get 60 minus 60, which gives you a 0. Just small quick remark here. My matrix D is not the 0 matrix, but the determinant is equal to 0. And we're going to be using that property, which is quite strange a bit later on. What happens when you have these matrices that are such that the determinant are equal to 0? But anyways, for that little section on how to compute 2 by 2 slash 1 by 1 determinant, that's it. That's all. Bye-bye.